So today we're going to finish up section 5. It's the last section that we're going to cover. It is on the test on Thursday. So we're going to be solving equations with complex numbers. So what we're going to do here is use the same techniques that we did in 1-4. We're going to solve using the even square root property or the square root method. We're going to complete the square and use the quadratic formula. The only difference is you're going to end up with negative square roots, so we're going to get i's in our answers. So let's go ahead and do a few examples, and then the rest of the class time will be to work on your homework. So the first example, notice this is set up perfectly to solve using the square root method because my square term is isolated. So I'm going to go ahead and just square root the left side, square root the right side. When you have a square and a radical symbol, it cancels. So the x minus 2 comes out. And then I'm left with plus or minus the square root of negative 20. I now need to simplify the square root of negative 20. I could break it into negative 1 times positive 20. And then break the 20 into 4 times 5. Now, if you did 2 times 10, you would have to keep going. Let me just rewrite this left side. So now I'm going to square root the negative 1, it becomes I. Square root the 4, it becomes 2. No 5s to pair up. So this side will simplify to 2i square root 5, and it still has the plus minus in front. And now I just move the 2 over. So I'll add 2 to both sides. So final answer here is x equals 2 plus or minus 2i square root of 5. Yes?
If this is on a word sign, you would have to input both the plus and the minus as 2 different.
You've tried that? More than likely, and it'll probably tell you to do with a comma. Just read how it's listed. Sometimes they'll tell you enter both, separate it with a comma. Just read the questions as we see it. I'll take a look at the WebAssign and I'll let you guys know after we do these 7 examples or 8 examples. All right, next one. Same thing, it's already set up perfectly to use the square root method. Because notice on the left side, my square term is isolated. So I'm going to square root the left side, square root the right side. Square rooting that 3x minus 1 squared just makes it come out. And then here I could break the 48 into negative 1 times 48. And now I got to simplify the square root of 48. I could simplify it into 16 times 3. Now if you did 2 times 24 or 6 times 8, you'd still keep breaking down till it's prime. So now the right side will simplify into 4i square root 3. Because this will square root to an I, this square roots to a 4, and then the 3 stays underneath. Drop down this side, and now I'm going to move the 1 to the other side by adding it. 3x equals 1 plus or minus 4i square root 3, and then divide everything by 3. So x is equal to 1 plus or minus 4i square root 3 over 3. If you want to pull it apart and make it separate fractions, you could also say 1/3 plus or minus 4i square root 3 over 3. Either one of these would be acceptable. Number 3 and 4, I'm going to do completing the square. Now, if the homework doesn't specify, you can choose whatever method you want. On the test, they will specify which method to use. So be able to demonstrate quadratic formula, completing the square, whatever technique it says to use. So here we go. I'm going to do completing the square. Question? Yes. So first thing I need to do is make sure that the number in front of x squared is a 1, and it is. So I'm going to move the 5 to the other side. That's the next step. Move the constant to the other side. Leave the blank space. Next, take the b term. Divide it by 2. Square it. This is what you're going to add to both sides. Again, over here, I'm going to just put it in to what it was before I squared it. It makes my life easier when I go to factor that trinomial, because this will just factor into x plus 1/2 squared. I actually have to do the math here, though. I need to find a common denominator. So my common denominator is going to be 4. So I'm going to change the -5 into a -20 over 4. And then when I add these, I get -19 over 4. So this equals -19 over 4. That's what I got when I added those. Now I apply the square root method. Square root left side, square root right side. The left side, just the x plus 1/2 comes out. When I square root this side, I get plus minus. Now I can square root the -19 and the 4 separately. The square root of -19 becomes I square root 19, and the square root of 4 is 2. So that's what I'm going to put here. And now you move the 1/2 over. So final answer, x equals -1/2 plus or minus I square root of 19 over 2. If you want to combine it into 1, you could do -1 plus or minus I root 19 over 2. Either one. Pretty good there? All right, I'm going to do the next one with completing the square also. So number 4, we're going to complete the square. Again, make sure that the number in front of x squared is a 1. It is. So then I move the constant to the other side. So now I have x squared plus 3x, leave the blank space, equals -10. Take the b term, divide it by 2, and square it. My b term is 3. Divide by 2. When I square it, I get 9/4. So here I'm going to put plus 9/4. Here I put what it was before I squared it. Factor the left. Add this up. So I need to find a common denominator. It's going to be a 4, so I'm going to change the -10 into -40 over 4. And then subtract. So this equals -31, and that shouldn't be a 9, that should be a 4. And now I apply the square root method. Square root, x plus 3/2 equals plus and minus. 31 I can't break down, but I can pull the I out for the negative sign. And then I can also square root the 4 and make it a 2. Move over the 3 over 2. And you get x equals -3 over 2 plus or minus I square root 31 over 2. If you want to make it with just one denominator, you can write it like this and just put a 2 underneath. Pretty good. All right, let's try number 5. Remember, there is no such thing as the sum of two perfect squares, so I can't factor this, but I can use the square root method. So I would minus the 25. because I'm isolating the x squared, and now I square root both sides. Square root, square root, square root. Remember, I could break down the negative 25 into negative 1 times positive 25. So then this just becomes plus and minus 5i. Number 6, I believe I did the quadratic formula yesterday, but I'll do it again. So I'm going to demonstrate quadratic formula. Now you could also do completing the square on this one. You just can't factor it. It's not factorable. So for quadratic formula, my a equals 1, my b equals 2, and my c equals 9. I'm going to plug it into the formula. Negative b plus or minus b squared minus 4 times a times c, that's all under the square root, divided by 2 times a. Negative 2 plus or minus 2 squared is 4. And then negative 4 times 1 times 9 is negative 36. 2 times 1 is 2. I'm going to subtract what's under the radical, and I get negative 32. And now I have to break down the square root of negative 32. Do not be tempted to simplify those 2's yet. Break down the radical first. So negative 32, I can break it into negative 1 times positive 32. And then I'm going to break the 32. I'm going to make it 16 times 2. So this becomes 4i square root of 2. So now I have negative 2 plus or minus 4i square root of 2 over 2. I can simplify now. 2 goes into the 2 once, 2 goes into the 4 twice. So final answer here is negative 1 plus or minus 2i square root of 2. The last two, I'm just going to do the square root method. Pretty good on 6? Okay. Number 7. Again, remember your goal. I can't factor this. It looks like it's 2 perfect squares, but again, there's no such thing as the sum of 2 squares. So I'm going to subtract 9. 25x squared equals negative 9. I want to isolate the x squared, so I'm going to divide by 25. And now I can apply the square root method. Square root, square root. I can square root the negative 9 and the 25 individually if that helps. Square root of negative 9 is 3i. Square root of 25 is 5. So final answer here, plus or minus 3i over 5. Yes?
I square rooted it first and
Okay, that's fine. The proper steps is to isolate just the x squared. All right, next one. Same thing, square root method. Again, remember, our goal is to isolate the square term. So the first thing I want to do is divide both sides by 3. So then I get x minus 1 squared equals negative 16 over 3. I can square root both sides. X minus 1 comes out. Again, you can square root the 16 and the 3 individually. So this turns into 4i. This I can't, so I leave it. Next thing I need to do, this has got a radical still. I need to rationalize. So I need to get rid of that square root of 3. And the way that I do that is multiply top and bottom by square root 3. So now it becomes plus or minus 4i square root 3 over 3. I still have this side, and now I can move the 1. So x equals 1 plus or minus 4i square root 3 over 3. If you want to make it have the same denominator, then I would need to make this turn into have a 3 in the bottom. So then I could times top and bottom by 3. And then I could make this 3 plus or minus 4i radical 3 over a single 3. But you can leave it like that. So that is it for the 5b, or the 1.5b. Again, it's the same thing we did. The only difference is we end up with negative square roots, and we have to pull out an I. So that's the 1.5. So now what you're going to do is for the remaining 20, let's see how long we got, 30 minutes. So for the remaining 30 minutes, you can work on your 2 homework assignments. Now, one other thing I want to show you is some common questions that I've already gotten this morning.